For a 400 amp service, the National Electrical Code, or NEC, Article 225 dictates the minimum wire size. You'll need to use 4/0 American wire gauge, or AUG, aluminum, or 3/0 AWG copper. To purchase disconnect switch boxes, visit electrical supply stores or home improvement centers. Specifically ask for main lug disconnect switches rated for 400 amps. Remember that the wire from the meter to the weatherhead and the wire from the weatherhead to the disconnect switches must be run in electrical conduit for protection. Always ensure proper grounding of the entire system, adhering to the NEC guidelines. It's strongly advised to have your electrical work inspected by a licensed electrician before energizing the system. Always consult with a qualified electrician for personalized advice tailored to your specific situation and local electrical codes. Firstly, let's delve into the wire sizing requirements for your 400 amp service. As previously mentioned, the NEC mandates a minimum wire size of 4/0 AWG aluminum or 3/0 AWG copper for this application. It is imperative to adhere to these guidelines to ensure the safe and efficient operation of your electrical system. The choice between aluminum and copper conductors often hinges on factors such as cost, availability, and specific installation requirements. Copper, known for its superior conductivity and corrosion resistance, is generally preferred for smaller gauge wires and critical applications. Aluminum, on the other hand, offers a more cost-effective solution for larger gauge wires, where its lighter weight and lower material cost become significant advantages. When selecting the appropriate wire size, consider the ambient temperature, the number of current carrying conductors in a raceway or cable, and the terminal temperature ratings of the connected equipment. These factors can influence the ampacity of the conductors and necessitate adjustments to the wire size to ensure compliance with the NEC. Secondly, let's explore the selection and procurement of disconnect switch boxes. These devices serve as a critical safety feature, allowing you to quickly and safely to energize the electrical circuits in your house and garage apartment in the event of an emergency or during maintenance activities. When purchasing disconnect switch boxes, specify main lug disconnect switches rated for 400 amps. Main lug disconnects are designed to accept large gauge conductors directly, providing a robust and reliable connection point for the main service entrance conductors. Ensure that the disconnect switch boxes are listed and labeled by a recognized testing laboratory such as Underwriters Laboratories or all to verify their compliance with applicable safety standards. Consider the enclosure type of the disconnect switch boxes, selecting a NEMA-rated enclosure that is appropriate for the intended environment. For outdoor installations, choose a NEMA 3R or NEMA 4 enclosure to provide protection against rain, snow, and ice. Thirdly, let's address the importance of using electrical conduit to protect the wiring from the meter to the weatherhead and from the weatherhead to the disconnect switches. Conduit provides a physical barrier that shields the conductors from mechanical damage, moisture, and other environmental factors. The NEC mandates the use of conduit in many applications, particularly where conductors are exposed to physical damage or are installed in wet or damp locations. There are several types of electrical conduit available, including rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or IMT, and rigid polyvinyl chloride conduit, or PVC. The selection of the appropriate conduit type depends on the specific installation conditions and local electrical codes. RMC and IMC offer superior mechanical protection and are often used in applications where conductors are subject to heavy impact or abrasion. EMT is a lighter weight option that is suitable for indoor installations where physical protection requirements are less stringent. PVC conduit is corrosion resistant and is commonly used in underground installations or in areas exposed to corrosive chemicals. Fourthly, grounding is an essential aspect of electrical safety, providing a low impedance path for fault current to return to the source. A properly grounded electrical system helps to minimize the risk of electric shock and equipment damage in the event of a ground fault. The NEC specifies detailed requirements for grounding electrical systems, including the sizing and installation of grounding electrodes, grounding conductors, and bonding jumpers. Ensure that the grounding system is installed in accordance with the NEC and local electrical codes. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, ground plates, or underground metallic water pipes. The grounding electrode is connected to the service equipment enclosure and the neutral conductor of the electrical system, providing a direct path to ground. Grounding conductors are used to connect non-current carrying metal parts of electrical equipment to the grounding electrode system, ensuring that these parts are at ground potential. Bonding jumpers are used to connect different metal parts of the electrical system together, creating a continuous ground path. Fifthly, a thorough electrical inspection is crucial to verify that the electrical installation complies with the NEC and local electrical codes. An electrical inspection can help to identify potential safety hazards and ensure that the electrical system is installed correctly and safely. It is highly recommended to have your electrical work inspected by a licensed electrician or qualified electrical inspector before energizing the system. The inspector will examine the wiring, grounding, bonding, overcurrent protection, and other aspects of the electrical system to ensure compliance with applicable codes and standards. Any deficiencies identified during the inspection must be corrected before the system is approved for use. The information provided here is intended for general guidance only and should not be relied upon as a substitute for professional advice from a licensed electrician. Electrical work can be dangerous, and it is essential to consult with a qualified professional to ensure that the work is performed safely and correctly. Furthermore, let's expand on the specifics of wire sizing for your 400 amp service. When determining the appropriate wire size, it's crucial to consider not only the ampacity of the conductors but also the voltage drop. Voltage drop refers to the reduction in voltage that occurs as electricity flows through a conductor over a certain distance. Excessive voltage drop can lead to reduced equipment performance, increased energy consumption, and even equipment damage. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. To calculate voltage drop, you'll need to know the length of the conductor, the current flowing through the conductor, and the resistance of the conductor. Online voltage drop calculators are available to simplify this calculation. If the calculated voltage drop exceeds the recommended limits, you'll need to increase the wire size to reduce the resistance and minimize voltage drop. In addition to voltage drop, consider the dirting factors that may apply to the conductors. Dirting factors are adjustments to the ampacity of conductors that are necessary when multiple conductors are installed in a raceway or cable, or when the ambient temperature is high. The NEC provides tables that specify the dirting factors that must be applied in various situations. When applying dirting factors, it's essential to ensure that the adjusted ampacity of the conductors is sufficient to carry the intended load. Next, let's delve deeper into the selection and installation of disconnect switch boxes. Disconnect switch boxes are available in a variety of configurations, including fused and non-fused versions. Fused disconnects provide overcurrent protection in addition to the disconnecting function, while non-fused disconnects only provide the disconnecting function. The choice between fused and non-fused disconnects depends on the specific application and local electrical codes. Consider the interrupting rating of the disconnect switch. The interrupting rating is the maximum amount of fault current that the disconnect switch can safely interrupt. Ensure that the interrupting rating of the disconnect switch is adequate for the potential fault current at the installation location. When installing disconnect switch boxes, follow the manufacturer's instructions and the NEC guidelines. Securely mount the disconnect switch box to a stable surface and ensure that all connections are tight and properly insulated. Use appropriate strain relief connectors to prevent stress on the conductors at the point of entry into the disconnect switch box. Now let's discuss the different types of electrical conduit and their applications. Rigid metal conduit, or RMC, is the heaviest and most durable type of electrical conduit. It is typically made of steel or aluminum and is used in applications where conductors are subject to severe physical damage or corrosion. RMC is often used in industrial settings, underground installations, and outdoor applications. Intermediate metal conduit, or IMC, is a lighter weight version of RMC that offers similar levels of protection. INC is typically made of steel and is used in applications where physical protection is required but the weight of RMC is a concern. Electrical metallic tubing, or INT, is a thin-walled conduit that is typically made of steel or aluminum. EMT is used in indoor applications where physical protection requirements are less stringent. EMT is easy to bend and cut, making it a popular choice for residential and commercial wiring. Rigid polyvinyl chloride conduit, or PVC, is a non-metallic conduit that is corrosion-resistant and lightweight. PVC conduit is used in underground installations, corrosive environments, and applications where electrical isolation is required. When installing electrical conduit, use appropriate fittings and connectors to ensure a secure and watertight connection. Support the conduit at regular intervals using conduit hangers or straps. Follow the NEC guidelines for conduit fill, which specifies the maximum number of conductors that can be installed in a particular size of conduit. Let's further discuss the critical aspects of grounding your electrical system. The grounding electrode system is the foundation of the entire grounding system. The NEC specifies the types of grounding electrodes that are permitted and the methods for installing them. Ground rods are commonly used as grounding electrodes. They must be at least 8 feet long and must be driven into the ground until at least 8 feet of the rod is in contact with the soil. Ground plates are another type of grounding electrode. They must be at least 2 square feet in area and must be buried at least 30 inches below the surface of the earth. Underground metallic water pipes can also be used as grounding electrodes. However, the water pipe must be in direct contact with the earth for at least 10 feet. The grounding electroconductor connects the grounding electrode to the service equipment enclosure and the neutral conductor of the electrical system. The grounding electrode conductor must be sized according to the NEC guidelines. Grounding conductors are used to connect non-current carrying metal parts of electrical equipment to the grounding electrode system. These conductors must be sized according to the NEC guidelines and must be installed in a manner that provides a low impedance path to ground. Bonding jumpers are used to connect different metal parts of the electrical system together. These jumpers ensure that all metal parts are at the same potential, reducing the risk of electric shock. Finally, let's emphasize the importance of a comprehensive electrical inspection. Before energizing your new 400 amp service, it is imperative to have it inspected by a qualified electrical inspector. The inspector will verify that the installation complies with the NEC and local electrical codes. The inspection will include a visual examination of the wiring, grounding, bonding, overcurrent protection, and other aspects of the electrical system. The inspector will also perform tests to verify the integrity of the grounding system and the proper operation of the overcurrent protection devices. Any deficiencies identified during the inspection must be corrected before the system is approved for use. Remember, working with electricity can be dangerous. Always consult with a licensed electrician for personalized advice and assistance. And always follow the NEC and local electrical codes to ensure a safe and compliant electrical installation. Also, it's always good to have an understanding of permits required and following all local codes when upgrading electrical services.